Dear students, welcome to all. Myself Rambabu, Physics faculty from Nuclear Academy, Bangalore. In this session of video, we will study the force of interaction between the charges. The force of interactions between the charges given by the Coulomb's law. So first we will learn what is the formula for Coulomb's law, how Coulomb's law can be stated, and after that we take relative formulas related to the Coulomb's law. See here, Coulomb's law in electrostatics, because here we are going to study about the electrostatics where charges are at rest or stationary. See here, I am going to consider the two charges, and already we studied in the properties of charge, like charges are repel and unlike charges are attract with each other. Here I am going to consider the two charges Q1 and Q2, both are positive charges. When the positive charges can be taken, in between the positive charges there is repulsive force can be exist. See here, Q1 is applying force on Q2, means it repel Q2 in this direction. So this is force on 2 due to 1. Similarly, Q2 is applying force on Q1, that is the repulsive force in this direction. This is force on 1 due to 2. Correct? So this force can be taken as a repulsive force. In the similar way, here I consider the another situation, two charges can be taken, Q1 and minus Q2. Here I am going to consider unlike charges. When unlike charges can be taken, Q1 attract Q2, similarly Q2 attract Q1. So means the force on 1 due to 2 in this direction and force on 2 due to 1 is in the towards Q2. So here this is known as repulsive force and it is known as a attractive force. According to Coulomb, the force of attraction or the force of repulsion between any two charges is the force of attraction or the force of repulsion between any 2 point charges is directly proportional to product of magnitude of the charges and inversely proportional to square of the distance between them, and the forces are acting along the line joining between the charges. So this is the line joining between the charges, the force is acting along the line joining between charges. Correct? Once again, the definition of the electrostatic force or Coulomb's law is nothing but the force of attraction or repulsion between any two charges is directly proportional to product of their magnitude and inversely proportional to square of the distance between them, and the force is acting along the line joining between two charges. See here, we are going to take the expression for Coulomb's law. According to Coulomb's law, force is directly proportional to product of the magnitude of the charges and inversely proportional to square of the distance between two charges. Now here, this proportionality constant can be removed. We are going to take K. A constant, proportionality constant can be removed. Proportionality is removed and we take a constant K into Q1 into Q2 by R square. Now it can be written as Q1 into Q2 divided by K. K is nothing but 1 by 4 pi epsilon naught into R square. So this is known as a Coulomb's force. The force between the two charges is directly proportional to product of magnitude of the charges and inversely proportional to square of the distance between them. That proportional can be removed. We will take the constant K. The constant K is nothing but 1 by 4 pi epsilon naught into Q1 Q2 by R square. So here this is known as the Coulomb's force, and here epsilon naught is known as permittivity of free space. Epsilon naught can be written as a permittivity of free space. Permittivity of free space, and we will take What is the value of the epsilon naught? Value of epsilon naught is nothing but 8.854 into 10 to the power minus 12. And unit can be taken, 1 unit is farad per meter. But here, as per this concept, I am going to take the unit. If epsilon naught is taken to the LHS, force can be taken to RHS, then epsilon naught is equal to Q1 Q2 by 4 pi into force into R square. Here the unit can be taken as numerator charge square, Coulomb square per Newton into meter square. The unit of the epsilon naught is nothing but 8.854, means the value of the epsilon naught is nothing but 8.854 into 10 to the power minus 12 Coulomb square per Newton into meter square. And next one, K value. K value is nothing but 1 by 4 pi epsilon naught. K value is 1 by 4 pi epsilon naught. If all values can be substituted, pi value and epsilon naught value, we will get this value 9 into 10 to the power 9. Here 4 pi does not having any units, epsilon naught is having the units, but it is reverse because it is taken in denominator. That is, K value is 9 into 10 to the power 9 Newton meter square per Coulomb square. So like that we are going to take the values of epsilon naught and value of the K. Okay? And after that we are going to take vector form of the Coulomb's law, because force is a vector quantity. See here, when we take the like charges, this repulsive force is in this direction. Whenever you take the unlike charges, in between them attractive force. Particular force must and should have the direction because it is vector quantity. Now we are going to take vector form of the Coulomb's law. The vector form of Coulomb's law is nothing but, here I am going to take F bar is equal to K into Q1 Q2 by R square. This is the formula from Coulomb's law. And direction of force is acting along the line joining. The direction is always given by the unit vector. Here R cap is the direction of the force along the line joining between them. So that is represented with the R cap. But we know that unit vector A cap can be represented as magnitude of A vector divided, means A vector, any vector A cap can be taken, it is represented as A vector divided by magnitude of A vector. So similarly R cap can be written as R vector by magnitude of R. So finally vector form of Coulomb's law can be taken as K into Q1 into Q2. R cap can be written as R bar divided by magnitude of R. Already R square is there. R square into R, which is nothing but R cube. So this is about Coulomb's law formula, terms present in the Coulomb's law and vector form of Coulomb's law. After knowing the vector form of Coulomb's law, next we will study about the term permittivity. See here, before going to study about the term permittivity, we have to take limitation of Coulomb's law. Coulomb's law is having two limitations. The Coulomb's law is applicable for only point charges. This is known as point charge. Coulomb's law is only applicable for the point charges. And next one, it is applicable when distance between the charges is greater than 10 to the power minus 15 meters. Distance between the two charges is more than 1 Fermi, then only it can exist. You know what is the 10 to the power minus 15 meters? It is the size of the nucleus. Whenever, if you are going to get the distance is 10 to the power minus 15 meter or 1 Fermi, in between them nuclear forces are exist. But whenever distance is more than the 10 to the power minus 15 Fermi, then only the Coulomb's law can be applicable. Okay? So remember, two limitations for Coulomb's law. Coulomb's law is only applicable for the point charges. Second one, Coulomb's law is applicable when distance between the charges is greater than 1 Fermi or 10 to the power minus 15 meters. If distance is equal or less than 10 to the power minus 15, then nuclear forces are exist. Okay? And after that, here we are going to take permittivity of a medium. Epsilon naught is representing permittivity of a vacuum or permittivity of a free space. But here we are going to take permittivity of a medium. Permittivity of medium can be taken as epsilon. Epsilon can be taken as permittivity of a medium. So here it is the ability of the medium to allow the electric field lines to pass through it. It is defined for dielectrics. If you want to define the dielectrics, we are going to use the permittivity of medium. So here, what is the permittivity of the medium? So it is the ability to allow, the electric field lines through it. Now, dielectric constant or relative permittivity. So here dielectric constant or relative permittivity, it can be represented with epsilon or either k. Any term can be used. Generally, epsilon r is representing relative permittivity of medium and k is also known as relative permittivity, but it can be generally used as a dielectric constant. Okay. Now see how to get the expression for relative permittivity. Here I consider the two charges. First, those two charges are placed in a free space. When two charges are placed in free space, then the force between two charges can be taken as, according to Coulomb's law, 1 by 4 pi epsilon naught into q1 q2 by r square. This is the force between two charges. Again, the same forces are placed in a medium which is having the dielectric. Whenever we place those charges placed in a dielectric medium, whenever those charges are placed in a dielectric medium, now the force in medium can be taken as 1 by 4 pi epsilon naught into epsilon r into q1 q2 by r square. In the free space, force is q1 q2 by 4 pi epsilon naught into r square. In the medium, force is q1 q2 by 4 pi epsilon naught into epsilon r into r square, where epsilon r is known as relative permittivity or dielectric constant. In sometimes dielectric constant is also represented with the term k. Now here I am going to consider the equation 1 and 2. I take the ratio of the both equations. Force in air divided by force in medium can be taken. So from that I can get it as q1 q2 by force in air is 4 pi epsilon naught into r square divided by force in medium is q1 q2 by 4 pi epsilon naught into epsilon r into r square. See, what are the terms cancel? q1 q2 cancel, 4 pi epsilon naught r square, 4 pi epsilon naught r square cancel, 1 by 1 divided by 1 by epsilon r, finally it can be written as epsilon r. The relative permittivity can be taken as the ratio of force in air by force in medium. So from that we are going to take force in medium is equal to force in air divided by epsilon r. So here from this what we can understand, the force can be considered in the medium which is always less than force in air, where epsilon r can be known as relative permittivity of medium. Relative permittivity. And here we are going to take the formula for epsilon r is known as permittivity of the medium, absolute permittivity of medium divided by permittivity of free space. And here it is dimensionless quantity. It is dimensionless and there are no units. Epsilon naught, epsilon are having same units, where epsilon r does not having any units. Here permittivity of medium, relative permittivity or dielectric constant, and already we studied permittivity of the free space. Okay? So this is about the limitations of Coulomb's law and permittivity of the medium. And after this, we are going to learn about superposition principle of forces. Superposition principle is nothing but there are number of forces acting at a point. Then how to calculate the net force. So coming to the superposition, we are using this concept to find the forces, charges which are placed at the corners of the triangle, charges placed at corners of the square, like that. Whenever charges are placed at corners of the hexagon, in the type of number of charges system is given, to calculate the force, we are going to use superposition principle. What is the superposition principle? The resultant force on any point charge due to number of point charges is the vector sum of the forces due to number of point charges. Why I am taking the vector sum? Because force is a vector quantity. So due to that reason, we can add the force by using vector rules like parallelogram law, triangular law can be used. So here also I am going to take expression for the force depend upon the superposition principle. See here, I am going to consider a charge Q. On the charge Q1 and Q2 are applying forces, like that I can assume n number of charges. Whenever force is acting on the charge Q, due to the charge Q1, that is lying along the line joining between Q1 and Q2, this force can be taken as F1 bar. Similarly, Q2 is also applying force on Q along the line joining, this force can be taken as a F2 bar. Now I am going to calculate what is the resultant force. Resultant force is nothing but this is the resultant force. For getting the resultant force, I am going to apply the vector rule. Means vector addition can be taken. Vector addition will follows the parallelogram law. So you know the formula for parallelogram, that is root of a square plus b square plus 2ab cos theta. We can use that. By using that, we can get the net force. Here I am going to write generalized formula for n charges. So here the force due to the charge 1 on Q is nothing but K into Q into Q1 by R1 square along R1 cap. Similarly, force on Q due to Q2 can be taken as K into Q into Q2 divided by R2 square along R2 cap. Like that, I am going to assume n number of charges. The force due to nth charge can be taken as K into Qn by Rn square along Rn cap. Now here all the forces can be added vectorically, means the net force is nothing but vector sum of the n forces, Fn bar. And here it can be written as F1. F1 is nothing but K into Q1 by R1 square along R1 cap plus F2 can be written as K into Q into Q2 divided by R2 square along R2 cap. Like that, I am going to consider n number of the charges, then charge due to nth charges, force due to n charges, K into Qn by Rn square along Rn cap. Now in all, I am going to take the common term can be taken as K into Q is the common. When K into Q is common, the remaining term is Q1 by R1 square along R1 cap plus Q2 by R2 square along R2 cap plus and so on, Qn by Rn square along Rn cap. So finally, we are going to take the expression for superposition of the Coulomb's law or superposition of the principle for the forces is F bar is equal to, in this the common term is K into Q and all are in addition. I am going to take sigma Qi divided by Ri square along Ri cap, where I can be taken as 1 to n. So this is the general expression for the superposition principle of the Coulomb's law. But for problem solving, we are going to apply the parallelogram law of vector addition. With the help of parallelogram of vector addition, the resultant force is equal to root of a square plus b square plus 2ab sin theta, 2ab cos theta. By application of this formula, you will get the resultant of forces. Correct? So this is about Coulomb's law and superposition of the Coulomb's law.